Ever wondered what mysteries lie beyond the blue horizon of Neptune? From its supersonic winds to its hidden ocean of liquid water, this distant giant planet is full of astonishing surprises. Neptune, the eighth planet from the Sun, remains one of the most enigmatic members of our solar system. What makes it so unique, and why does it capture our imagination? Join us for an incredible journey into the heart of Neptune's wonders, where science meets the extraordinary in a world of blue. Neptune is a windy wonderland. Neptune is a planet of extremes, and its winds are no exception. This gas giant holds the title for the fastest winds in the solar system, with speeds reaching up to 1,200 miles per hour. That's nearly 5 times faster than the strongest hurricanes on Earth. These incredible winds create a dynamic and chaotic atmosphere, with giant storms and dark spots moving across the planet's surface. The planet's winds are fueled by Neptune's internal heat, which radiates more energy than it receives from the Sun. This heat drives massive convection currents, creating powerful jet streams and vortices that rage across the atmosphere. These winds give Neptune its ever-changing weather patterns, despite its frigid distance from the Sun. One of the most famous weather features on Neptune was the Great Dark Spot, a storm system the size of Earth. Discovered by the Voyager 2 spacecraft in 1989, this giant storm vanished just a few years later, showcasing the dynamic nature of Neptune's atmosphere. Scientists are still studying what makes Neptune's winds so extreme. The planet's unique combination of internal heat, atmospheric composition, and rapid rotation all play a role, but the exact mechanisms remain a mystery. The winds of Neptune are a testament to the raw power of planetary weather, offering a glimpse into a world where nature reigns supreme. The deep blue mystery of Neptune's color. Neptune's striking blue color is one of its most defining features, but it's not just a simple reflection of the sky. This rich azure hue comes from methane in the planet's atmosphere, which absorbs red light from the Sun and reflects blue light back into space. However, methane alone doesn't fully explain Neptune's intense coloration. Scientists believe that there are other, unknown components in the atmosphere that enhance the blue tone. These mystery molecules have yet to be identified, making Neptune's appearance as much a scientific puzzle as it is a visual marvel. Neptune's vivid blue sets it apart from its neighbor Uranus, which also contains methane but appears a paler shade of blue-green. The subtle differences in atmospheric composition between these two planets highlight just how unique Neptune truly is. The planet's color isn't just an aesthetic feature, it provides valuable clues about the composition and chemistry of its atmosphere. By studying Neptune's blue, scientists gain insights into the processes at work on this distant world, and even on exoplanets that share similar characteristics. Neptune's mesmerizing blue reminds us of the beauty and complexity of our solar system, where even the color of a planet holds untold secrets. The discovery of Neptune was a mathematical marvel. Neptune's discovery in 1846 wasn't a stroke of luck, it was a triumph of mathematics and astronomy. Scientists noticed that the orbit of Uranus wasn't following predictions, suggesting the gravitational pull of an unseen planet. Using calculations, French mathematician Urbain Le Verrier pinpointed Neptune's position without ever looking through a telescope. When German astronomer Johann Galle aimed his telescope at the predicted spot, Neptune was there, just as Le Verrier had calculated. This marked the first time a planet was discovered through mathematical prediction rather than direct observation, a breakthrough that changed the course of astronomy. Interestingly, English mathematician John Couch Adams had also made similar calculations around the same time, leading to a controversy over who deserved credit for Neptune's discovery. In the end, both Le Verrier and Adams are recognized for their contributions. Neptune's discovery also underscored the power of Newton's laws of motion and universal gravitation, which formed the basis of the calculations. This event cemented the idea that mathematical models could predict the existence of celestial objects, a concept that continues to guide modern astronomy. The discovery of Neptune stands as a testament to human ingenuity, showing how the mind can uncover worlds hidden from the eye. Neptune's rings are thin and wispy. Neptune is adorned with a set of faint, thin rings that add to its otherworldly charm. These rings, made of dust and ice particles, are far more delicate and less prominent than those of Saturn. There are 5 main rings: Gale, Le Verrier, Lassell, Arago, and Adams, each named after notable scientists who contributed to our understanding of the planet. What makes Neptune's rings unique is their clumpy and uneven distribution, a phenomenon scientists are still trying to understand. Some parts of the rings appear brighter and denser, forming arcs rather than smooth, continuous bands. These arcs are thought to be stabilized by the gravitational pull of Neptune's moons, particularly Galatea. The rings were first detected in the mid-1980s through ground-based observations and were later confirmed by the Voyager 2 spacecraft. Voyager's flyby provided detailed images of the rings, revealing their complex structure and composition. Despite their faintness, Neptune's rings hold valuable information about the planet's history and the processes that shaped its outer regions. By studying the rings, scientists hope to uncover clues about the formation of the outer solar system and the interactions between moons and planetary rings. Neptune's rings may not be as famous as Saturn's, but they are a delicate reminder of the intricate beauty found throughout the cosmos. Neptune is an ice giant with a hidden ocean. Neptune belongs to a category of planets known as ice giants, which are distinct from gas giants like Jupiter and Saturn. Beneath its thick atmosphere lies a mantle of water, ammonia, and methane ice, creating an interior vastly different from the gas giants. This icy composition gives Neptune its classification, but it also raises intriguing possibilities. Scientists believe that under the icy mantle lies a vast ocean of superheated high-pressure water. This ocean, kept in a liquid state by extreme pressure, could potentially harbor exotic forms of life or unusual chemical processes. Neptune's core is a rocky mix of silicates and metals, surrounded by this mysterious ocean. The transition from the icy mantle to the core is gradual, creating a layered structure that adds to the planet's complexity. The pressure and temperature in Neptune's interior are so extreme that methane molecules could break apart, forming diamonds. These diamonds might sink to the core, creating a glittering layer of solid carbon, a phenomenon often referred to as the diamond rain. Neptune's status as an ice giant with a hidden ocean sets it apart as a planet full of surprises, challenging our understanding of what a world can be. Neptune's moons are a diverse family. Neptune is home to 14 known moons, each with its own unique characteristics. The largest and most famous is Triton, a fascinating moon with a retrograde orbit, meaning it orbits Neptune in the opposite direction of the planet's rotation. This unusual motion suggests that Triton was likely captured from the Kuiper Belt, a region of icy objects beyond Neptune. Triton is a world of wonders, featuring geysers that spew nitrogen gas, a thin atmosphere, and a surface covered in frozen nitrogen and methane. Its geologically active surface makes it one of the most intriguing moons in the solar system, and a prime candidate for future exploration. In contrast to Triton's icy splendor, Neptune's smaller moons are less dynamic but no less interesting. Proteus, the second largest moon, is oddly shaped and heavily cratered, suggesting it has remained relatively unchanged for billions of years. Nereid, another notable moon, has one of the most eccentric orbits of any moon, swinging dramatically closer and farther from Neptune. These moons offer a glimpse into the diverse processes that shape planetary systems. Some moons are likely remnants of Neptune's original satellite system, while others, like Triton, are later additions. Studying them helps scientists understand how moons form and evolve over time. Neptune's moons are a microcosm of the solar system's complexity, each contributing to the rich tapestry of this distant planet. Neptune's magnetic field is misaligned and tilted. Neptune's magnetic field is unlike any other in the solar system. It's both off-center and tilted at a staggering 47 degrees relative to the planet's rotational axis. This means that Neptune's magnetic field is constantly shifting, creating a wildly dynamic magnetosphere. The magnetic field is generated by electric currents within the planet's icy mantle, rather than in a metallic core as on Earth. This difference in origin contributes to its unusual properties, including its irregular shape and strength. In some regions, Neptune's magnetic field is up to 10 times stronger than in others. This chaotic magnetic field produces spectacular auroras, much like the northern and southern lights on Earth. However, Neptune's auroras are more scattered and less structured, appearing as patches of glowing light near the poles. The planet's unique magnetosphere also interacts with the solar wind in ways that are still not fully understood. Voyager 2 provided the first glimpses of Neptune's magnetic behavior, but many questions remain about how it affects the planet and its surrounding space environment. Neptune's magnetic field adds another layer of intrigue to this distant world, highlighting the diverse ways planets generate and sustain magnetic forces. Neptune's year lasts 165 Earth years. A year on Neptune is an extraordinary 165 Earth years long, meaning it takes nearly 2 centuries to complete one orbit around the Sun. Since its discovery in 1846, Neptune has completed just one full orbit, which occurred in 2011. This lengthy year is due to Neptune's vast distance from the Sun, about 30 times farther than Earth. At this distance, the Sun appears much smaller in Neptune's sky, providing only a fraction of the light and warmth that reaches our planet. Despite its slow orbit, Neptune rotates rapidly on its axis, completing a day in just 16 hours. This rapid spin, combined with its elliptical orbit, creates fascinating seasonal variations. Each of Neptune's 4 seasons lasts more than 40 Earth years, resulting in gradual but significant changes in atmospheric activity. Understanding Neptune's lengthy year and slow seasonal shifts provides valuable insights into the dynamics of planetary orbits and climate systems. The planet's orbit also places it in a region of the solar system that offers clues about the formation of outer planets and the migration of celestial bodies. Neptune's epic year serves as a reminder of the vast scales of time and distance that define the outer reaches of the solar system. Neptune was the last stop for Voyager 2. In 1989, NASA's Voyager 2 spacecraft became the first, and so far only probe to visit Neptune. This historic flyby provided humanity's closest look at the distant planet, revealing breathtaking details about its atmosphere, moons, and rings. Voyager 2 captured stunning images of Neptune's vibrant blue clouds, powerful storms, and faint rings, transforming our understanding of the planet. It also made groundbreaking discoveries, such as the presence of the Great Dark Spot, the dynamic weather patterns, and Triton's geysers. The spacecraft's instruments measured Neptune's magnetic field, confirming its tilted and off-center configuration. Voyager 2 also provided data on the planet's temperature, wind speeds, and atmospheric composition, laying the foundation for future studies of ice giants. Voyager 2's flyby lasted only a few hours, but its legacy endures. The mission's data continues to inform scientific research and inspire new questions about Neptune and its role in the solar system. The encounter with Neptune marked the end of Voyager 2's planetary tour, but the spacecraft remains a symbol of humanity's quest for knowledge, now traveling through interstellar space as a messenger of discovery. Neptune may hold clues to the formation of exoplanets. Neptune's status as an ice giant makes it a valuable analog for studying exoplanets, planets beyond our solar system. Many of the exoplanets discovered so far are Neptune-like in size and composition, falling into a category known as mini-Neptunes or sub-Neptunes. By studying Neptune, scientists can better understand the atmospheric processes, magnetic fields, and interior structures of these distant worlds. Neptune's dynamic weather, deep blue hue, and icy mantle offer a template for modeling the conditions on similar exoplanets. One of the most intriguing aspects of Neptune-like exoplanets is their potential habitability. While Neptune itself is inhospitable, its characteristics help researchers identify which exoplanets might have liquid water, stable atmospheres, or conditions suitable for life. Future missions to study Neptune up close, such as orbiters or atmospheric probes, could provide critical data for interpreting observations of exoplanets. These missions would also deepen our understanding of how planets like Neptune form and evolve in different stellar systems. Neptune's connection to exoplanet research highlights its importance not just as a member of our solar system, but as a key to unlocking the mysteries of the universe. Neptune is a planet of mysteries, extremes, and beauty, offering a glimpse into the farthest reaches of our solar system. From its supersonic winds to its hidden ocean, Neptune continues to captivate scientists and dreamers alike. If you enjoyed this exploration, be sure to like, share, and subscribe to Innovision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the wonders of the universe with us.